two mediums. One medium is air, another is glass. Ray of light falls from air to glass prism on the first surface. After that, it passes through the glass, and on the next surface, it is coming from glass to air. Therefore, there are two refractions. One is from air to glass on surface first, and glass to air on surface 2. When the ray of light is entering from air to glass on the surface 1, it bends towards normal according to the law of refraction, and on the second surface, ray of light coming from glass to air goes away from normal. In this way, the incident ray and last is emergent ray, both are in the different paths. Spectrum of light. The band of 7 colors formed on a white screen when white light passes through a prism is called a spectrum. White light is falling from air to glass. Then there are two phenomena. One is deviation. Deviation means bending of light, and another is dispersion. Dispersion means splitting of white light into 7 colors. We are knowing that letter Vibgyor. There are 7 colors in white light. Prism only split or separate out these 7 colors, and it is not creating any color. Recombination of 7 colors to give white light. This is an activity to prove that light is having 7 colors. Prism is separating out 7 colors but not producing 7 colors. White light is falling on a prism A, P1 prism here, that is A is the angle of prism, and it is splitting into 7 colors. R and V are shown here. Then another prism is kept in the opposite position, means reverse position, that is base is in upward direction, and this prism, second prism, is combining all the 7 colors and producing again white light. It means that prism is splitting white light into 7 colors, and second prism is recombining 7 colors into white light. That is, light is having only 7 colors. Prism is not producing any color. It is only separating or splitting the color. Deviation, the bending of ray from its original direction, is called deviation. Deviation means bending of light, simple meaning. Angle of deviation, angle between direction of incident ray and emergent ray. Emergent ray is the ray coming out from the prism finally, that is emergent ray, and this angle is shown in the figure. Incident ray, red color ray is falling on first surface of the prism. Then this incident ray converts into refracted ray inside the prism, and this refracted ray comes from glass to air again, and this last ray is known as emergent ray. In this way there are 3 rays: incident ray, refracted ray, and emergent ray. The angle between direction of incident ray shown by dotted having arrow at the end, and another is emergent ray. That angle is known as deviation angle or angle of deviation. Here the prism is shown in the figure. Incident ray is falling on the first surface, and this is now became refracted ray inside the prism after refraction, and this refracted ray becomes emergent ray after coming in air again. In this way, first ray is incident ray, then second is incident ray is converted to refracted ray, and finally emergent ray. BC the base at which the prism is kept, and just opposite to BC there is angle A, that is known as angle of prism. Here the angle of prism is 60 degree. This is an equilateral prism. All the angles are 60 degree. The incident ray makes an angle with normal N and S on the point E, that is angle of incidence. Similarly, the emergent ray makes an angle with the normal M dash, and that is small e. The angle between direction of incident ray, that is GH, and emergent ray RS, is known as angle of deviation or deviation angle, capital D. Here there is diffraction angle, small r. Actually this is an activity in the physics laboratory. We place the prism on a cardboard having a plain paper, A4 size paper, and then draw the boundary of the prism with the pencil. Then place two pins P and Q in front of the surface AB and keep our eye in position AC in front of surface AC and observe the direction of ray coming out. Then we observe this incident ray inside the prism, and PQ appears in the direction R and S, that is two pins PQ became P dash Q dash apparent position, and another RS. All the four appears in a single line. Then take out R and S pin and draw a line from the point joining R to S, that becomes emergent ray. Dispersion of light. Splitting of white light into its 7 colors vapor is known as dispersion of light. The 7 colors of light travel at different speed through the glass prism. Speed is the cause of reflection. When ray of light goes from air to, say, glass, then speed of light decreases. When ray of light goes from glass to air, speed of light increases. And this is the region that ray of light bends from its direction. In this figure, white light is coming from air to glass, and there are two things. One is deviation. Deviation means bending of light. Here another thing is dispersion. Dispersion is splitting of white light. Both are shown in the figure. Deviation, number one. Number two, dispersion. And it is observed in the diagram that red color is deviating least, violet color is deviating most. More deviation means refractive index is more. Less deviation, refractive index is less. It means refractive index of for red color is less, refractive index for violet color is maximum in the diagram. Rainbow appears in sky The rainbow is an arc of 7 colors visible in the sky, which is produced by dispersion of sunlight by raindrops in the atmosphere. The raindrops in the atmosphere act like a prism. Let I explain more. When there is rain, then tiny droplets becomes available in the atmosphere. These tiny droplets behaves like a prism. When the sunlight passes through these tiny droplets, they behave like a prism and separate 7 colors. These splitted 7 colors appears in the sky in the form of rainbow. Rainbow is the natural spectrum found in universe. Again the diagram is shown here, rainbow in sky. In the right hand side diagram, sunlight is coming inside the water droplets and it is refracted, means it is deviated also, as well as dispersion occurs. These 7 colors now comes inside the eye, outside the tiny droplet, and inside tiny droplet there is another phenomena, that is total internal reflection of light. Total internal reflection of light, 100% light reflect inside the denser medium, and this light 100% reflected comes out through refraction outside the tiny droplet. The star appears or seems higher than their actual position. When a ray of light enters from sky, means rarer medium, as well as we go upward position, the air becomes rarer, and medium becomes also rarer. We are coming closer to the Earth's surface. So many gases are there: sulfur dioxide, carbon dioxide, nitrogen oxide, and so many gases. Then medium becomes denser. Then closer to the Earth, denser medium. Away from Earth, rarer medium. There are two mediums becomes in air. Ray of light coming from a star bends successively due to refraction from rarer medium to denser medium. This ray of light finally arrives in human eye, and the final image is formed in the direction of dotted ray as shown in the figure, and apparent position of the star is different from the real position, that is apparent image is higher than the actual position of the star. Advance sunrise and delay sunset. When the ray of light enters from sky means there are rarer gases, due to which rarer medium available at a height, and to the atmosphere means near the ground, denser medium. Then due to refraction, the ray of light bends successively towards normal on the various layers of air and arrives in eye. The refracted ray in the backward direction makes the image of sun at a higher point in the sky. Therefore, the image of sun appears at a higher position due to refraction of light. Even the sun is below the horizon. In this way, we get 2-minute advantage for sunlight during sunrise, and again 2-minute sunlight during the sunset. It means total 2 plus 2 is equal to 4 minutes extra light becomes available due to refraction of light in the atmosphere. That is the advantage of atmosphere around the sun to get 4 minutes extra light in the atmosphere. Here there is refraction. Stars are twinkling. You can observe in the figure. Twinkling of stars means appearance and disappearance of light in our eye, that is known as twinkling, and this is due to refraction of light in atmosphere. There are disturbances in the different layers of air due to movement of air or any other region. Therefore, sometimes the little amount of light arriving in our eye goes inside the eye, and next moment it becomes outside the vision, as a result of which appearance and disappearance occurs in human eye, and that is known as twinkling of stars. Scattering of light. The intensity of scattered light is directly proportional to the horsepower of frequency or inversely proportional to horsepower of wavelength. This is the Rayleigh rule. Scientist Rayleigh worked for scattering, and this is the reason that blue light is scattered much more strongly than red light, because wavelength of red light is more, scattering of light is least. Opposite to it, violet or blue color here have the highest frequency, lowest wavelength, scattering becomes more, according to the rule given by scientist Rayleigh. Why is color of clear sky is blue? The fine particles in air whose size is of the order of wavelength of light. Condition is here. Size of particles whose approximate size is equal to or order means nearby wavelength of light, they scatter only. Scatter the blue color shortest wavelength more strongly than red color of white light. The scattered blue particles this blue light enters in eye and sky appears blue. The sky appears dark to the passengers flying at a very high altitude, because at very high altitude there is no atmosphere, no scattering of light, due to which the sky appears dark. Color of sun appears red at the sunrise and sunset. Due to scattering of various colors, we know that violet, blue color scattered more, red color scattered least in the atmosphere. The ray of red color light only arrives in eye, and the sun appears red in color during sunset and sunrise. Remaining other colors scatter in the sky and sky appears blue. Danger signal light are red in color. The red color is scattered least by the fog and smoke. According to the scientist Rayleigh rule, scattering is directly proportional to 1 upon wavelength to the power 4. Red color wavelength is more and scattered least. Therefore, red color light arrives in eye, and this is the reason that red signal can be seen from a large distance. Tyndall effect is also based on scattering of light. In the left hand side figure, rays of light from sun are entering in dense forest. Tiny droplets are available on the leaves of the forest, trees in the forest. When the ray of light falls on these tiny droplets, they also scatter light, and this figure shows here a scattering of light. Another diagram is also there in which a colloidal solution. Colloidal solution examples, we are having medicine, syrups in the market, and these syrups are supplied in the colloidal form. Ray of light from the source is falling on a convex lens, and that is converging light, and this converging light is falling on the particle of colloidal solution. Then it is scattered in all possible directions, and the appearance of bluish color in the solution is observed by the microscope. This is Tyndall effect. Now let us come to Tyndall effect. Tyndall effect, also known as Tyndall scattering of light, scattering by particles in the colloidal solution or particles in the fine suspension solution. In this experiment, a colloidal solution containing tiny particles of sulfur. Sulfur is in the dispersed form. Tiny particles are obtained by adding thio solution. Thio means sodium thiosulfate solution with dilute H2SO4 mixed inside it. Then sulfur becomes in the dispersed form, and this sulfur shows here scattering of light when white light falls on it. The bottle with a little milk appears bluish due to scattering of light, whereas the pure water bottle is brown. When the white light is falling on both the bottles close to each other, then the different action of the scattering observed there. Activity to show scattering of light. Here in a transparent beaker, there is a colloidal solution. Source S is placed at the focus of convex lens. The ray of light coming from the focus becomes parallel after passing through the lens. These parallel rays are falling in the on the colloidal particles inside the solution, and scattering of light occurs, due to which the solution, that is colloidal solution inside the transparent jar, appears bluish, and remaining red color passes, and that is collected by another lens L2, and it is converging at the focus on the screen shown in figure LM or MN, and this MN screen have a red color patch, round patch. Only red color is observed because remaining colors are scattered inside the colloidal solution. Here is dispersion and scattering of light is shown in figure. Second figure shows again scattering of light, and third and fourth also appearance of red color in the sky also at various positions of the sun. appearance of sunset, and that is due to